So we're still in section 11.1. This is ellipses day 2 notes. Just recall above that we have the equation for an ellipse, x minus h quantity squared divided by a squared plus y minus k quantity squared divided by b squared equals 1. And remember, when we're doing these equations, we want to have it in this form. The center of my ellipse in this case would be, of course, remember, h comma k. Now, if we look at this first equation, the first equation is in what we call general form. So for this, the first thing we would want to do is put this in the form of an ellipse. Now, how do I do that? I'm going to, just like we did for circles, have to complete the square. So the first thing you want to do is get your x squared terms and x's together and your y squared terms and your y's together, and then take the constant to the other side. So we're going to write 25 x squared plus, or minus, sorry, 50x minus 50x, and then we have plus 16y squared minus 128y equals 119. Now, remember, when you're completing the square, you cannot have a number in front of the variable. So the next step that I want to do is I want to factor out that number that's in front. So we're going to factor out the 25 here for x's. So we get 25 times x squared minus 2x. And then over here for the y's, we're going to factor out the 16. So when we factor out 16, we get 16 parentheses y squared minus 8y. Now, for this problem, if we're going to complete the square, remember that we want to add and subtract half our linear term squared. So that's the next step. So I have 25 times x squared minus 2x plus something to complete the square, and you always want to do the plus first, and then you have to subtract that number, because if you just add it, then you're changing the equation, but if you add and subtract it, you're canceling itself out, so you don't change the equation when you do that. So then we have plus 16y squared minus 8y plus something to complete the square minus that same number equals 119. Now, for these problems, I usually like to do them in different colors because it helps me keep track of the x's versus the y's, but you don't have to do that, of course. Now, for the first one, remember it's half your linear term. So here's my linear term. So half of negative 2 would be negative 1, and negative 1 squared is 1. So we're adding and subtracting that. For the next one, we have negative 8 for our linear term. So half of negative 8 would be negative 4, and negative 4 squared is 16. So we're adding and subtracting 16. Then for the next part, we're going to, remember, factor your equation with the 1 with the plus. So this part here, I'm going to be factoring that. So x squared minus 2x plus 1 factors into x minus 1 times x minus 1, which becomes x minus 1 quantity squared, because remember, it's always x minus half your linear term. Then don't forget we have minus 1 there. Then on the other side we have plus 16. And then when we factor y squared minus 8y plus 16, we get y minus 4 times y minus 4, which is y minus 4 quantity squared. If it helps you to write that step out, you're welcome to do that. Now, I'm still not in the form because I want to get those constants to the other side. However, I can't get the constants to the other side because the first thing I want to do is notice that this 25 is being multiplied here. So I need to distribute this 25 in first, and over here I'm going to distribute the 16 to my numbers. So when I do that, I get, move this down a little bit, so 25. And this would be x minus 1 squared minus 25. And then I have plus 16y minus 4 squared. And then 16 times 16 gives me 256. And that should have been minus 16. I didn't realize I wrote the plus there, because it's always minus the number. So minus 256 equals 119. So I just made it a little smaller so I can write. And then now we want to get all the constants to the other side. So I'm going to add the 25 to the other side. So that gets rid of this. And then I'm going to add the 256 to the other side. And so that gets rid of the 256. And now I'm going to go ahead and keep going. So I have 25 times x minus 1 quantity squared. And then we have plus 16 times y minus 4 quantity squared. And now it's equal to 400 when we add all that together. Then I'm still not done because remember before we said that these equations, if you look back up here, they must equal 1. So in order to get 1, I have to divide everything by 400. So each term, remember terms are separated by addition and subtraction signs, so divide each of those by 400. And then the last part is to simplify. So when I simplify here, I get x minus 1 squared over 16 plus, this side's going to be y minus 4 squared over 25. And then we have equals 1. So this is my equation that I have. And that gives me my answer. Another way of seeing people complete the square, if you prefer not to keep everything on one side, you can always take it to the other side. So sometimes people like to complete the square and whatever number you're factoring out, you would put that number here, and then whatever completes the square for that would go here for the x's, and then you would do the same thing. This would be 16, 16, and then you could do whatever completes the square here. So that would just be taking your constants to the other side and taking, instead of adding and subtracting the term, you just add it all to the other side. So you can do that if you want, or you can do it all together. It doesn't really matter. Now going back here, now we want to graph this. So the center is your h and your k. So h is with the x, so we have negative x minus 1, so your h is going to be opposite, so 1, and your k is opposite as well, so 4, so that gives me the center of the circle, so over 1 up 4, which would be right here. Now I know that here, since my larger number is over y, that means my major axis is going to be on the y-axis. I know that my a value is equal to 4 because remember that it's this is your a value squared is 16, so the square root of 16 gives you 4, and the square root of 25 gives you your b value. So this gives you your b value equal to a value of 5. So that means on the y, because remember you always look above in the numerator to tell you which direction to go. So since 25 is over the y, so that means we're going to go up 5 and down 5. And that's my major axis, and my minor axis, we're going to go right 4 and left 4. And then we can complete our ellipse as best as we can by hand. So that would be my ellipse. And then if it asked me to find the focal points, then what I would have to do is remember to find the distance, we call the c distance, c squared. You take the larger value that you have, so the larger value in my equation is 25 in the denominator, and subtract that from 16. So when we do this, we end up with so we end up with 9, so c squared equals 9, so c is equal to 3. So remember that your focal points are always on your major axis, which is the y. So from the center, we count up 1, 2, 3, and down 1, 2, 3. So that gives me my foci. And that would be my equation. So sometimes we're not always given the equation, sometimes we're just given different parts of the equation. So for example, we want to write an equation for the ellipse that are described below. Now for this one, it gives us that the major axis, and I know this is major axis because anytime you see M and A in capital letters, it means major axis. So that's 14. And then the focal points are at 4, 0, and negative 4, 0. So the first thing I would do, even if you're not given a graph, I would always draw a picture of this because it kind of helps you visualize what is going on in the problem. So we have 1, 2, 3, 4, 0, which is right here, and negative 4, 0. So negative 4, 0 is here, so positive 4, 0 would be over here. So that gives me my focal points, and I know that my major axis is 14. Well, if I add the distance between my focal points, I know that that's less than the length of your major axis. And so I know that this total length is equal to 8. And so I know that if the major axis is 14, well then 14 minus 8 gives me a value of 6. So that means I need to add 6 more. And of course, remember, since it has to be the same from the center, we're going to divide that by 2 and get 3. So that means for the vertices, I'm going to add 1, 2, 3 to each of those points. And I know that those are the ends of my graph. So I know that the distance from here all the way to here is going to be a distance of 14, which is my major axis. And because my major axis is 14, that also tells me, remember, half that distance is going to be your A. So 14 divided by 2 gives me 7 for my equation. Now the only thing I need to find is my B value, because right now I can even look here and tell that the distance in between the two means that the center of my circle is going to be here at 0, 0. So I know the center is at 0, 0. So we have the equation x minus h. So x minus 0 squared would just be x squared over a squared. Same thing with y. So y squared over b squared equals 1. Now I just need to figure out what b is equal to. So if we know what our a is, remember we have the equation c squared is equal to, and since my major axis is 14, I know it's going to be 14, not 14, sorry, a squared. So a is 7, so 7 squared minus b squared. C, we know, is the distance from the center to the focus, which is right here, the focal point. So if that distance right there is a distance of 4, then I know this is going to be 4 squared here. So 4 squared is 16 equals 49 minus b squared. So then I want to take the 49 to the other side. When I solve, I get b squared is equal to 33. I don't even need to take the square root of that because I want a squared and b squared in my equation. So a squared in this case is going to be 16, and b squared is equal to 33. So this would, 16, so sorry, I meant to say a squared is 49 because our a value is 7. So this would be my equation given the length was of the major axis was 14 and the focal points were at 4 and negative 4. And of course we know that this is a horizontal ellipse because the major axis is on the x-axis. So let's do one more. For this next one, it says the major axis endpoints are at 2, 8, and 2, 0. So I'm going to put those on my graph first. So here and here. So if that's the major axis, I can count the length of that. I know the length of that is going to be 8. And you can just count on your graph. The minor axis, and I know it's minor axis because it's a little m and a little a, have endpoints at 5, 4, and negative 1, 4. So if I want to figure out the length or the distance of the minor axis, I can just count. So this would be 1, 2, 3, 4, 5, 6. So I know that length is going to be a length of 6. So that tells me that if my major axis length is 8, then I know that half of that is going to be my A value. So half of that would be 4. And I guess I should use that as B, because remember we said that the major axis, since it's on right here, then I know that that's going to go underneath my Y. And if we have x minus h squared over a squared plus y minus k squared over b squared equals 1, then if my major axis is on the y, I should do b instead of a. So b is equal to 4. And then that means a would be equal to 3. So putting it into the equation, if I look, I can see the center of my circle because it's where the two are intersecting here. So I know that the center is at 2, 4. And then I can just write my equation. So I have x minus 2 squared over a squared, so a is 3 and 3 squared is 9, plus y minus 4 squared over b, which is 4, and 4 squared gives me 16. And all of that is equal to 1. So that would be my equation. So again, anytime you're not given the actual equation, you're just given the endpoints or you're given the focal points, you should always think about trying to put it on graph paper and make a sketch to help you figure out what the equation would be. Another helpful hint is usually I like to write out the actual formula for the equation. Writing it out multiple times kind of helps you memorize it, and it's kind of good to also help you visualize what you need for your equation. So just make sure to bring this with you to class and we can do some more practice.